Hey team, welcome to the next video in this series on Roadrunner for FTC. Again, this is using Roadrunner version 1.0. In previous videos, we've previously set up our robot. This is Bob, our test bot. It's configured with 4 drive motors, 3 dead wheel encoders, 2 on the side, 1 on the back. And for this video, we've also mounted a servo onto the front of Bob. That's that servo right there. It's got an orange horn on it. We're going to be spinning that servo. So this video is going to assume that a couple things. It's going to assume that you've set up the robot for Roadrunner, you've checked out the project, you've gone through the whole tuning process, and we end that tuning process with the spline test where your robot does a nice little arc across the field. What we're going to be doing for this video is actually getting our robot to do a little bit of autonomous work, not just driving around, but controlling that servo and specifically timing it so that it does what we want. So I'll show you what that's going to look like. Here's our finished Auton. The robot's going to drive forward a fixed distance, spin that servo in a direction for 3 seconds. So we're spinning to the left. It's going to drive backwards, spin that servo the other way for 3 seconds, and then stop. So pretty close to what our previous tuning classes were doing. Nothing terribly special here, but really we're going to be talking about that key way to mix in other actions into the robot. Roadrunner handles a lot of the driving for you, a lot of the get to this position logic, but it doesn't really tell you how to run your mechanisms on your robot, which you're going to be doing autonomous. So I'll go ahead and show you the code now. Here's the finished code that we're going to have for you. I've got it on the screen now. Just not to intimidate you, it's not that bad. It's only 70 lines of code. For this for this video, I am going to expect that you know a little bit of programming. I'm not going to be going over too much of the basics. Hopefully you've written or seen a little autonomous, so you know how the linear op mode works. There's a run op mode method. This gets called when you hit initialize on the phone. You know how to get some stuff from our hardware map, like a servo. If you've done the previous tuning video, this mechanism drive class you'll get for free. Wait for start, we'll wait for the play button to get pushed, and then I'll be explaining how to run a series of actions in order, both using the action builder and then this static run blocking method here. Yep, Roadrunner gives us some built-in methods we'll be calling, so line to X, and build, and stop and add as well are all built into Roadrunner. And then we're going to be making some custom actions, and those actions implement the action interface given to us by Roadrunner, and that's going to move our servo. One of them is just going to set position on the servo and let it run. The other one's going to have a 3-second timer on it so that we're going to wait for that servo to spin as well. So this is all the code we're going to be writing. We're going to be doing this basically from scratch. So let's go ahead and get started with that. First thing we're going to do is make a new file. So we're going to go down to our team code folder, new Java class, and let's call this first Roadrunner Auton. We're not going to add this to Git yet. This is going to extend linear op mode, same way all of our Auton files do. Android Studio promptly yells at us and says, you're not implementing methods. So if you hold Alt and hit Enter, and then hit Enter again to implement methods, run op mode is what we want. So that's going to stick it in for us. And then we also need to annotate this as well with that autonomous annotation. Autonomous, and give it a name. First Roadrunner Auton. So hopefully that all looks familiar to you. If you already have another Auton file, you can just reference that, and it's going to get you this far as well. The things we're going to be doing in here, typically you would do your all your hardware map gets in here, or if you already have classes for your mechanisms, you would initialize those in here using that hardware map. In this case, we're going to be using the mechanism drive class that we previously configured to use Roadrunner. So this is the file that when you download the Roadrunner package, we changed some parameters in here in the previous video. This gives us all of our tuning parameters, and it tells us how our robot is set up with that 3 dead wheel localizer and our motor directions and all that. So this mechanism drive is going to be handling all of the hardware map getting for us, which is nice. So in our first Roadrunner Auton, we're going to have mechanism drive, new mechanism drive, And this takes a few things, our hardware map, and a new pose. So our pose is going to be the starting position of the robot. It's pretty typical to just make it all zeros. So this would be a new pose 2D, and I believe this just takes 3 zeros. Things don't import automatically for you. Alt-Enter is the please do that for me. So hit Alt-Enter and then Enter again, and then that finishes that for me. We've also got a servo setup on the robot, so we do want to initialize that as well. That's just a standard FTC servo in terms of imports. This isn't a Roadrunner specific thing. Servo, we'll call it servo, and that's going to be hardware map get, servo, get, servo. And this servo we've already configured on our driver station. It's mapped to port 0 on the control hub, and that's all set up for us already. We're going to call wait for start. And hopefully at this point, this looks pretty familiar. So this mechanism drive, replacing a few of our drive motors might be different. Maybe, again, you already have your own class for it, but we are using mechanism drive, and that handles the initialization of those 4 motors, all in the mechanism drive class that we worked on previously. Great, so now we get to do some Roadrunner. I always like to start from a copy or a sample of something. Android Studio kind of fills in a lot of the blanks of, once you know you need a linear op mode to fill in the run op mode method for you and all that. So let's just go into manual feedback tuner. And in this file, this is what we had ran previously in a previous video. This is one that drives forwards and backwards forever. And we can just see how that's done and tell our robot to do something similar. So if we skim this code real quick, there's different if statements for our drive class, one for tank drive, one for mechanism. We are mechanism. It has this mechanism drive equals new mechanism drive, the constructor. We've already done that code, so that's nice. Looks like we did it correctly too. We have wait for start as well. And then they have a while op mode is active, which is essentially an infinite loop. It's actions run blocking, drive action builder, and it calls line to x distance, line to x 0 build. So the code I've highlighted here is actually what we're going to copy paste over. You can type this out as well, but we're going to copy paste it because it's easier. And then we need to move some distance. Previously it was 64 inches. We can just keep that in as well. Cool. So this is a pretty straightforward autom. We'll go over what this does real quick. Again, wait for start. Actions run blocking uses the actions framework within Roadrunner. The actions framework is basically a way to break down different actions that you can tell your robot to run in order. So an action is going to be drive to a position for Roadrunner or face a specific direction, wait for some amount of time. And it actually allows you to build your own custom actions as well. And we'll be doing that to get that servo to move within this Roadrunner actions framework. So actions run blocking says run these actions in order and make the first one finish before you call the second one. That's what blocking means. The action we're going to be making is based off of our drivetrain. So we're going to use an action builder to start at a pose. So starting 0, 0, 0. Move our x to 64 forward, then move our x to 0, and then build just means turn this into an action we can run. All right, let's go ahead and plug in the robot. I'm going to do that on the field here real quick, and we can run this code and make sure it works the way we expect. We're going to hit the upload button here. It's all successfully finished. If you see me tab over to OBS there, I'm just making sure that our recording's going okay, so don't know if you don't have that screen on your computer. All right, and then I'm going to switch views here and actually show you the robot on the field again, and we'll just watch it run that action. So you can run this through FTC dashboard. We set that up in a previous video. We're going to run first Roadrunner, don't mind the typo there. Set this up in a previous video, FTC dashboard. It's just nice because it shows you guys what I'm doing, basically that you would be doing through a driver station. It also shows you the trajectories. So in code, when we have the action builder with line to X, line to Y, face angle, whatever, you'll actually see that show up in this field view down here that I've got stuck into right side of the screen for us. So anyways, let's go ahead and run that. We'll hit initialize. We'll hit start. Watch that robot drive forward and then drive backward. There you go. So that's our first Roadrunner autonomous there for you. Not too bad, right? Line to X, and build. So again, we're going to run these in blocking order. This is drive forward to x64, and then drive back to x equals 0, and then build. Cool. So that's great and all, but we have, let's say, something we need to deliver, and that delivery is going to use something like a servo. So let's start using that servo. If you want to add more actions into this list of actions, then we just have to make a new class that implements action. So action is a specific class in Roadrunner. We've actually imported it up here as well. So actions, Roadrunner, FTC actions. And we can make a new class that is an action and then tell Roadrunner to run an instance of that action. So we're going to do something a little bit weird here that they do in the docs. You may or may not have seen this before, depending on how much Java you skimmed through. But we're going to be making a class inside of our class. Yes, you can do that. So we're going to make a new class here, public class servo action. And this is defining a new class inside of our class. So if you want, this could be its own file, and that's totally valid as well. But just so it fits on the screen, we can see how it's used. We're gonna make this in its inside of this other class. So this servo action needs to be a Roadrunner action for Roadrunner to know how to run it. So actions and interface. So we're gonna do implements action. And you'll see Android Studio nicely highlights it red and says, whoa, if you're an action, you have to implement the things that action does. So we hit Alt-Enter, hit Enter on implement methods, hit Enter one last time to implement that run method. And now we have a servo action. So you can see what Roadrunner classifies as an action. An action is anything that implements action and has this run function that returns a Boolean. So we just need to tell Roadrunner, when you run this action, do whatever happens inside of run, which isn't that bad. So inside of here, we need to move our servo. So inside of run, we're just going to do servo.setPosition and set it to some position. And we've already got two problems. We don't know what position we're setting it to. We don't know what servo we're moving. So in this action, we're going to make a constructor, servo action, and it's going to take a servo and a position that servo is going to move to. And we're just going to save that on the action. So this dot servo equals s, this dot position equals p, and then of course our instance variables, we need to have a servo, servo s, and position p. Oops, excuse me, double position. Servo is servo here. There we go. Great. So now when we make this action, which we'll be making pretty soon here, we're going to say, okay, if you give me a servo and a position, when this action is run, we will set position on this servo. So it's kind of like a two-step process. It's the preparation of you got to tell Roadrunner what we're going to be working with. And then when Roadrunner is ready to run it, it's going to call run for us. And that calls set position, right? We do return a Boolean here. This basically says, are we going to keep calling this code? Does this action need more time to run? We're just going to return false immediately for now. We'll play with this more later. This just says we are done running this action. So run's going to get called once. We're going to call set position. It's going to return false, and we'll never get called again. All right, so now how do we weave this action into our actual code? So after we call line to X, we're actually going to call stop and add, and that's going to take an action. So stop and add. And here we can give Roadrunner a new action for it to call run on. So we're actually going to call new action. Whoops. New servo action, excuse me. And we're going to pass it our servo and some position that's going to go to. Now this is a continuous servo, so I'm just giving it a position of 0, which is going to spin it one of the two directions. But depending on your mechanism, you might have a specific position you want it to go to. All right, so notice how I interweaved this line of code here. This is an interesting pattern in Java called a builder pattern. So these are not individual lines of code. This is actually one line of code here. This builder pattern, the way it works is you pass it, it has built-in methods, essentially, that every time you call it will return the same builder. You can keep calling methods on it over and over and over. Once you're done, you call build, and this will return basically an action that wraps all of these inner actions. So notice there's no semicolon here. We are just calling line to X, that returns something. Then we're going to call stop and add on that value, that returns something, which we're then going to call line to X on, which returns something, which we call build on, which returns an action that we end up using. So that's an action builder. If that went over your head, don't worry about it. Just know that there's no semicolons here. We're just going to kind of chain all of these methods together. All right, so that's stop and add, and we added that servo action. So we're going to plug the robot in again and run that code and see how our robot behaves. All right, robot's plugged in here. We're just going to push some code. In the meantime, go ahead and think what you think this is going to do. We're going to go line to X. We're going to tell the servo to start moving, and then line to X is 0 to go back to that starting position. So we're pretty sure that the robot's going to go forward and come back. But we're mostly curious about how that servo gets weaved into those two actions. Let's get that screen up for you. And then once everything's set up, first Roadrunner auton, and then start. So the robot's driving forward, starts driving backward as the servo starts spinning, and then it stops. So it did exactly what we told it to do, which could be good or bad. If we go to our code, we can kind of see what it did. It did go line to X. The robot did stop, and we added the servo action. That servo action did tell the servo to start going to that position to start spinning. And then we immediately went line to X while that servo was spinning. So this may or may not work for your robot. Let's pretend for this robot that we're trying to deliver some kind of game element into some area. And as soon as we move that servo, the robot can't start driving. We need to have the element leave our robot so we can score points for it. So there's two ways to do that. There's a simple way, which is just calling wait seconds here. So we can just put wait seconds in, and that's going to wait 3 seconds for the robot to deliver that game element. So let's push that code and see how that behaves now. So hopefully we see it, again, drive forward, start spinning that servo, wait for 3 seconds while that servo spins, and then drive backwards. Push some code here. Show you the robot view here. Got to unplug it again real quick. And then inside FTC dashboard, once the robot's done resetting, oops, click too fast. Roadrunner auton, and then start. We're going to drive forward. Servo starts spinning. We're waiting for 3 seconds, and then that robot drives back while the servo is still spinning. So we actually never told that servo to stop spinning, which is kind of fun. So let's go to our code and see how we could do that. We do have this stop and add. So we drove forward, we spun the servo, waited 3 seconds, and told it to move back. So we never told that servo to stop spinning. So let's just add a few more actions in here. So after we wait 3 seconds, let's maybe tell that servo to stop spinning. And then after we go to X, we could do something like tell the servo to spin the other way, and then wait some number of seconds. And you kind of see how you can weave in an action here that would do something like move a servo. So if this feels like enough for you to run your autonomous, go ahead and use this pattern as is. This video is going to keep going for a little bit longer as we talk about some more advanced ways to use actions. But if all you need to do is set power to something or move a servo or something basic, feel free to just use this pattern where you're calling stop and add and wait seconds. However, if you want to learn a little bit more, the next thing we're going to do is kind of see how we can combine this servo action with wait seconds. And this will let us do things like control servos a little more precisely, as well as set positions on motors and maybe wait for those motors to get to a specific position. So we have our basic servo action down here, and we talked about this return value briefly before. This return value right now just says return false, which means as soon as this run method is called, we're going to say do not call us again, this action has been completed. And we saw if we don't have a wait seconds after we call that action, the robot just goes to the next action while that servo keeps spinning. So let's make a new servo action, and we're going to have this one actually wait a fixed amount of time until the action says it's done. So let's just call this a patient servo action, and we'll change our constructor name as well. All right, so our patient servo action is also going to take a servo in a position. It's going to move its servo to that position. However, we don't want this action to be done until maybe 3 seconds have passed. So to do that, we're going to have this action keep track of how long it's been running for. So we're going to use an elapsed time class, which you may have seen in some of the sample files or used on your own before. I think they call it stopwatch or something for the variable name, but I like the name timer here. And then in our run method, we now kind of have to check if we've been running or not and how long we've been running for. So you'll see this pattern a lot if you look at actions in a lot of the sample code that Roadrunner has for you. But what we're going to be doing is checking if timer is null. Then we want to start our timer. And essentially what this does is it says the first time you call run, first time Roadrunner calls run, we're going to say, ooh, have we run before? If not, timer must be null, and we're going to start that timer. Then we're going to set our servo position, and now our return is going to be conditional, right? We want to see how long we've been running for to know if we need to keep running. So again, the way this return value works is, do we need to keep running? We get to answer that question for Roadrunner. So remember, run returns true or false. True means I'm running still. False means I don't need to run anymore. So in this case, it depends if we need to keep running. So if our timer seconds is less than 3, let's say we need to run for 3 seconds. So under 3 seconds, we're now going to return true and say, yeah, we do need to keep running, right? So if we're less than 3 seconds, we're going to return true. Otherwise, we're going to return false. So if it's only been 1 second, this would be the case. 1 is less than 3. We're going to return true, and Roadrunner is going to say, you're still running. Let me keep calling you. And eventually, 3 seconds will pass. This will be false, and we'll come down here and return false. Now, there is a quicker way to write this. Android Studio kind of gives a hint by this hover here. You can simplify this if-else statements. We're going to do that because it's fun. So we're just going to return timer .seconds less than 3. So this is if we've been running for less than 3 seconds, return true, which is the same as just saying return running less than 3 seconds. Another thing that you might find as a useful pattern here is the way this is set up right now, every time run is called, and it's going to get called a lot by Roadrunner, because again, we'll keep returning true. Roadrunner might call this maybe a few hundred times over those 3 seconds. We're going to keep calling servo.setPositions. This code runs every time. This is okay for a servo. Telling it to run to the same position over and over isn't going to hurt anything. But you might find it useful with other things to have some kind of initialized code inside of your if statement up here. So this will behave the same whether you tell a servo to run to a position once or every loop, it's still going to run to that position. However, you could imagine maybe this is a motor and you need to set the run mode, but you only want to do that once, like to reset the encoders. And you would do that inside of something like an if statement here. Another common practice is if you don't have a timer, sometimes you just need to keep track of have I been run before. And the easy way to do that is Boolean has initialized. And then in your run, you can just check if has initialized. And if you haven't, you can do something. So this is a nice way that you can have some kind of setup code in your run statement so that the first time this is run, maybe you set a target position and set a mode on your motor, set them to run using encoders or run to target position or stop and reset. All of that code would go here where you only want it called once. And then your return for maybe something like a DC motor could be something like motor get position is equal to your target position, right? And then you can do the same thing but with the motor instead of servo. Hopefully that makes sense. For now, we're just going to use this timer though. If you go through some of the other examples and docs as well, you might see that initialize flag as well. That's another common way to solve that problem. Cool. So this is a different action that we just made. This is a patient servo action. We're going to use that up at the top. So let's just replace this first chunk here. Instead of a servo action, a patient servo action. And now we don't need this wait seconds. So the way this will work now, let's drive to x is 64. So we're going to drive forward 64 inches. We're going to stop and add a patient servo action, which is going to wait for the 3 seconds. And then we're going to turn our servo off by setting it to 0.5. We're going to drive backwards. And then let's do another patient servo action down here so we can get rid of this wait seconds 3. And this is kind of nice because, maybe this isn't a patient servo action. Maybe this is a open claw action, which is going to have the same code, but it's just going to be called open claw instead. And the time that takes to do that might be consistent, right? Like every time you open the claw, it might take 1.5 seconds. So you can hard code that 1.5 into the open claw action, and it knows itself how long it needs to run without this code needing to know. So let's push that code one more time and see how it runs. This should be, I think, our final version of the code here. We're just going to plug the robot in. Push new code. All right, and then we'll unplug the robot. I'll switch cameras so you can see the robot on the field. Oops, wrong button. There we go. And then we'll run this Roadrunner Auton, which now uses our patient servo actions. So we're going to drive forward. Servo starts spinning, 3 seconds, stops spinning, comes towards us, and then spins the other way for 3 seconds before stopping. Sweet. So that's exactly what we expected it to do, which is pretty cool. Again, just stepping through the code one more time so you can see it all top to bottom. We have our new first Roadrunner Auton class. Make sure you have that autonomous tag so it shows up. In run auto mode, we have our mechanism drive file, which holds our drive motors, and our servo, which we just get from a hardware map. We wait for that start button before calling actions run blocking. This runs all of these actions in blocking order, so the first one will finish before the second one starts. All these actions we're calling is line to X to drive forward. We're going to call stop and add with some custom actions here. Some of our actions, like servo action, just return immediately, so they don't take any time to run. They're basically not blocking actions. They just immediately say, I'm done. However, our patient servo action uses the clever use of a timer here to wait some number of seconds until it says it's done running. So this will keep being called for 3 seconds. We learned kind of how to initialize some stuff also in this run method, so we can keep track of something like if a variable is null, or we can check if an initialized Boolean is true or false to run something once. All right, the last thing I wanted to show off was actually a little bit of the Roadrunner docs. So all we've had the robot do is drive forward and backwards, and you might be wondering how to drive the robot different ways. So the docs aren't fully complete, but if you go to builder reference here in the docs, it'll show you a couple different options. So we've been using line to X and line to Y. So this says get to that coordinate while facing this heading. So you can see the robot actually drives to the X equals 48, even though it's facing this direction. Line to Y does a similar thing. Spline to will start giving you curves, and you can, since we don't have internet because I'm connected to the dashboard here instead, but you can hit the play button on these videos here and just kind of see how the robot faces. This is halfway through a tangent heading, so you can set tangent to say which way the robot should be facing. and then spline to a position, which gives you that curve. There's also spline with heading, so the heading can change over time. Just go ahead and play with some of these. In the code, there's quite a few more. So there's strafe to, which you might find useful. There's also a turn or turn to. So turn will turn some amount, turn to faces some heading if you need to rotate the robot in some way. And with basically those things, you should be able to get everything working that you need to. Just strafing, turning, and facing the right way, and then driving X and Y, and then splines if you want a nice curved line. Also, one other thing to note, if you do want to clean this up a little bit, your Auton file might end up having tons of actions in it. You can move these actions out into a mechanism class. So for example, we could move this into a class called claw or something. Then at the top, we would have maybe our mechanism drive and a claw class, which would take our hardware map. And then the way to do that is you would put your actions in your claw, and then in the claw class, you would have a method which creates a new action and returns it. You'll see that pattern in the Roadrunner docs as well. If you go to, I believe, building a center stage autonomous, this section here has a really nice explanation of how to do that and kind of just combine all of the files separate your files so that things are a little more organized in your code. But if you're just looking for a quick, simple Auton to get Roadrunner to drive around and move some servos and motors, this should get you pretty far as is. All right, I think that's all I wanted to show up. Hopefully you have a better idea of how to take your fully tuned robot and get it to drive around the field. Play with some of these driving functions, the strafing, the line twos, the spline twos, the turn to and turn methods, and then start creating some custom actions as well and shove those in and see how everything behaves. Don't forget there's also the wait seconds method, which is useful just in general if you need the robot to take a break on the field for some amount of time. All right, thanks for watching. Good luck.